Hi, so in this session we are going to discuss more bitwise operators. So these operators are very useful as well. So first we are going to discuss AND bitwise operator. So you had already seen one logical AND operator that is different from this. Logical AND in C++ and Java is like AND, or in Python it's like AND. So this is in C++ and Java, and Python it's AND. So these are logical AND operators. So what it does is, so it does something like true and true. So it works on boolean, something like true and true, true and false. So if we'll do 5 and 4 in this, so 5 is greater than 0, so it will be true. 4 is greater than 0, it will be true. True and true is true. If we will do like this. But this AND operator works bitwise. So how it works bitwise? So the concept is 0 1 1 0 0 0 and 1 1. 0 and 1 is AND operator. 0 and 1 is 0. 1 and 0 is 0. 0 and 0 is 0. 1 and 1 is 1. So AND operator with any 0, this is bitwise, is 0, but 1 and 1 is 1. So if you will generalize this, if I am x bit, so x and 1 and x and 0 is what? X and 0 is definitely 0. That is same. X and 1 is what? X and 1 is depending on this. 0 and 1 is 0. 1 and 1 is 1. So it will be x. So this is a general formula for any x bit. If you will do x and 1, it will be x. X and 0, it will be 0. So let's say take an example, 4 and 5. What will be the value? So you will see this. Let's say 0 0 0 0. 4 is something like this, and 5 is 1 0 1. So 0 and 1 is 0. 0 and 0 is 0. 1 and 1 is 1. 0 0 0. All of them will be 0. So this value is actually 4. If you will do in programming 4 and 5, you will get the answer 4. So it works with bitwise. 0 and 1 is 0. 0 and 0 is this. 1 and 1 is this. So we are working on that, and this is how AND operator works. And this is generalization. X and 1 is x. X and 0 is 0. Okay. That is a general operator. Let's discuss another operator, that is OR. OR works like this with single stick, and logical OR in C++ and Java is like this operator, and in Python it's like OR, something like this. So what it does is true or true. It works on boolean like this. True or true is true. True or false is false, something like that. Okay, these are the logical OR operator, but this is a bitwise OR operator. So what its generalization is 0 1 0 0 1 0 1 1. 0 or 1 is 0 or 1 is 1. 0 or 0 is 0. 1 or 0 is 1. 1 or 1 is 1. This is how it is like this. So if you take any x bit, x or 1 and x or 0, x or 1 is definitely 1, and x or 0 is definitely 0 or 0 is 0. 1 or 0 is 1. So it will be x depending on x. If it will be 0, it will be 0. If it will be 1, it will be 1. Okay. According to that, this is our generalization. So if we will do 4 or 5, it will be like 1 0 0. I am writing just 3 bits. This is like 1 0 1. Rest of the bits are 0. 0 or 1 is 1. 0 or 0 is 0. 1 or 1 is 1. Rest of them will be 0. So this value is actually 5. So if you will do 4 or 5, you will get the answer as 5. This is how bitwise OR operator works. This is our generalization. X or 1 is 1 and x or 0 is x. Okay. This is our concept. This is how bitwise OR operator works. Okay, we will be using them in many applications, so that's why that is important. What is AND operator, what is OR operator? This generalization is also important. What happens if we take any bit, if you do OR with 1, what happens in that? If you do OR with 0, what happens in that? Okay, great. Now let's discuss another operator, that is NOT operator, not bitwise operator. Okay, it's like this. So not bitwise operator, what it does is, let's say you have an x, it just flips the bit. So if you will do complement of 0, it's like complement of 0 is 1 and complement of 1 is 0. It just flips the bit. Okay, so if you will do any complement of x, it just flips all the bit. Okay. Okay, now one important thing is, if you will take any 4 number, let's say this, I am just writing 4 bits for now, 0 1 0 0. So if you will write in 4 bits, in 4-bit representation, if you will do if this is my x, negation of x will be, this will become 1, this will become 0, this will become 1, this will become 1. So its answer is coming out 11, but it will not happen like that because all bits will be flipped. So in 32 bits it will be like 1 1 1 1 1 initially. Okay, because all the bits 0 will be flipped into 1, so it will become like this. So negation of 4 in reality it comes out to be -5. Just in 4 bits, for understanding I've used that, it's coming out 11. Just the concept is that not operator flips the bit. If it was 0, it comes out to 1. If it was 1, it comes out to 0. Okay, so it just flips all the bits. So if you take negation of 4, this first 4, negation of 4 works like this. In 32 bits, it comes out to be -5. Okay, this is how not operator works. Now the fourth and important operator is XOR operator. This is also very important. Now its generalization is, if you take the table 0, 0, 0, 0, 1, 1, 0 and 1, 1. XOR operator is like this. 0 or 0 is 0. 0 or 1 is 1. 1 or 0 is 1 XOR 0 is 1. 1 XOR 1 is 0. So its generalization is X XOR 1 and X XOR 0 is what? Let's see. 0 XOR 0 is 0. 1 XOR 0 is 1. So if it will be X only. X XOR 1. 0 XOR 1 is 1 and 1 XOR 1 is 0. So it will be negation of X. If you want to flip any bit, you can do the XOR with 1. And if you want to get the same bit, you can do XOR with 0. This is our understanding, that 0 XOR 0 is this, 0 XOR 1 is this. If you will do 4 XOR 5, so it will be 0 1 0 0 and 0 1 0 1. You know that 0 XOR 0 is 0 only. So 0 XOR 1 is 1. 0 XOR 0 is 0. 1 XOR 1 is 0. It works like this. So 4 XOR 5, it comes out to be what? It comes out to be, okay, 0 XOR 1 is 1 and 0 XOR 0 is 0. 1 XOR 1 is 0. It comes out to be 1, and this is our final answer. So the important concept is, if you want to flip any bit, you can do this. If you want to have the same bit, you can do this. Okay, it works like this. The concept of table is this: 0 XOR 0 is 0, 1 XOR 1 is 0. If two same bits are there, then that will be 0. 0 XOR 1 is 1, 1 XOR 0 is 1. Okay, so that is the concept, and this is how XOR operator works. These are all operators which are needed for understanding bitwise operators, and we are done with left shift, right shift, and, or, not, and XOR. Okay, from next sessions we are going to see the applications of these all operators. How can we check ith bit and etc. We will be discussing a lot of applications, but make sure you understand all of these operators before going into that. Okay, great. Thank you.